Hello. In this video, we're going to talk about how to do a binomial test in Excel. So traditionally, an exact calculation for binomial tests is quite difficult because the formula for the binomial distribution is it has a combination term and a bunch of large powers, and then you have to sum individual values, and it's incredibly tedious. And so typically what one would do is somehow approximate the binomial distribution with the normal distribution and then do the test. But this binomial test is basically built into Excel. So we're going to see kind of as we wrap everything up at the end that it's really just a one-step process. So let's jump into it. So binomial tests, we have two outcomes, success and failure, and we have some predicted probability for the success. So just for an example, we're going to say that we think that regardless how the season goes, 98% of football fans don't change their favorite team from the beginning to the end of a season. And to test this, we did a survey and we found that out of 500 fans, 485 of them had kept their favorite team from the beginning to the end of the season. So, and now the question is at alpha is 0.5, is that sufficient evidence to reject the null hypothesis of 98%? Okay. So, all right. So just like any hypothesis test, first thing, the null hypothesis is going to be that the parameter is whatever the claim says it is, which is 98% in this case. And the alternative hypothesis, well, before we figure that out, let's figure out how many people we were expecting to keep their football team. So the expected number would be, well, 98% of the 500. So we were expecting 490 people to keep their favorite team. We only had 485, so we're a little low. So the alternative hypothesis then should be that the probability is less than 98%. Okay. And then the p-value is, well, what is the probability of getting the results we did, assuming the null hypothesis is true? So the p-value is, what is the probability that x is less than or equal to 485? Oh, I didn't have my shift key pressed. For less than or equal to 485 for a binomial distribution with n equals 500, e equals 0.98. Okay. If we were going to do this the old-fashioned way, well, remember the formula for the binomial distribution. It has a combination term. So let me just do the single value 485. So first of all, you have to choose out of 500 people, which 485 kept their team. And then each one of those 485 gets a factor of 0.98 because that's the probability that they kept their team. And each of the remaining people, so the 15 that are left, each get a factor of 0.2. Right? And so what is that equal to? So this would be the probability that x is actually equal to 485. And so the old-fashioned way, if you want to do this binomial test, you have to compute that probability for every number from 485 down, and then add those together, and that's your p-value. Thankfully, that cumulative probability is built into Excel now. So before we do the cumulative probability, let me do this single calculation again. So if I do binom dist, I put, well, the number I care about is 485 out of 500 trials with a single probability of 98. If I put a 0 here, so this last slot is called cumulative. So if I do not want cumulative, then it will give me the probability I just found, which is the probability of exactly 485 successes. Sure enough, it matches the number we just got. On the other hand, if I change that last slot, so I'm going to go binomial dist 485, 500.98. If I tell it I want the cumulative probability, then Excel will find the probability of every value up to 485 and add them together. And that's exactly what we said our p-value was supposed to be. So this is the p-value. And so now we see that this p-value is larger than alpha, so we fail to reject the null hypothesis. So there's not enough evidence at the 0.05 level to reject the claim that 98% of football fans do not change their favorite team from beginning to end of the season. It's entirely possible we just happen to get a group that changed a little more than you would expect. So, all right, that's it. Again, the point is that this whole computing the p-value was a single calculation. It's just binomial dist 485, 500.98, and tell it we want the cumulative distribution. There is one change we would need to make if we were doing a right tail test. So let's do a right tail test just real quick. Let's say same setup, but instead, let's go in our survey. 495 people did not change. Right. So now we have a higher value than the expected. So our null and alternative hypothesis are, well, the null is going to stay the same, but now the alternative will be that p is greater than 0.98. So instead of wanting the probability of x less than 495, we want the probability that x is greater than or equal to 495. Well, you just do the standard right-tailed trick. If you want the probability x is greater than or equal to 495, that's the same thing as 1 minus the probability x is less than or equal to 484. And so we would just do equals 1 minus binomial dist 484, or sorry, 494 out of 500.98 and 1. So, sorry. Just had a little typo. I mean, the point is that the opposite of being 495 or higher is being 494 or less. So, anyway, so 1 minus binomial dist 494, 500.1. So that's the probability that I am greater than 495. So again, this p-value we would fail to reject H0 in that case as well. All right, hope you enjoyed that, and we will see you in the next video.